This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. We're going to graph y equals 2 tangent of 3x. We're going to state the period, the equation of the asymptotes, and graph 2 full cycles, making sure we label the x and y axes, and using the dotted lines to show where the asymptotes are. Okay, so remember that the tangent graph, y equals tangent x, has a period of pi, but for our period, we have a 3 in front of the x, so your b is 3, so the period will take the usual period of tangent, which is pi, not 2 pi, like for cosine and sine, and divide by 3. So our period is pi over 3. Now, how does it go on the tangent graph? If there's no phase shift left or right, then we plug in 0 for x. Remember the tangent is 0, so 0, 0 is a point on the tangent graph, and that's sort of the center of the tangent graph. And since we have a whole period of pi over 3, we know if we go half of the period to the right and half of the period to the left, that's where our asymptotes will be. So what's half of pi over 3? In other words, what is half of pi over 3? That would be pi over 6, right? So if we go to the right, pi over, sorry, I don't know why that's going up. If this is pi over 6, and then we go to the left, pi over 6 units, that would be negative pi over 6. That's where asymptotes will be. And that is a full period of pi over 3, right? The distance between negative pi over 6 to pi over 6 is pi over 3 units. Now, of course, we have to do 2 cycles, so let's go ahead and draw where the next one would be. This would be pi over 6, 2 pi over 6, 3 pi over 6, or pi over 2. So you could either write 3 pi over 6 or pi over 2. It doesn't really matter. If you want to have a common denominator, you can keep it like this. Okay, so now we also are going to have this point in between here. All right, what about the rest of it? Okay, so the graph was y equals 2 times the tangent of 3x. And remember how it works with the y equals tangent of x right in between this point 0, 0 and the asymptote is where we're going to go up usually 1 unit, right? But since we have a 2, we're going to have to multiply it by 2, and we're going to go up 2 units. Now, what ordered pair is this, by the way? If you wanted to say, sorry, this is moving around on me. Well, now this is in between 0 and pi over 6. So again, what's half of the way to pi over 6? That would be pi over 12. So this little tick mark here is pi over 12, and we're going up 2. So if you wanted to write that ordered pair, it's getting crowded in here, but that ordered pair is pi over 12, 2. Okay, pi over 12, 2. There's the 3 key points on the tangent, and then we start down and we go through those 3 points, curving it. Now, same thing over here, in between this point on the x-axis, and let's label this as the x-axis, and this is the y-axis. We're also going to have to go over to the right, that space, and up 2 units, over to the left and down 2. And we have 2 full cycles. Now, once I look at the graph, it's easier for me to tell what the asymptotes are. So the equations of the asymptotes. They're vertical lines, so it's x equals, and you just take one of the asymptotes. It doesn't matter which one, so I'm going to choose this pi over 6 plus, now, to get the next asymptote, it's a full period to get to the next asymptote. And what's the period up here? Pi over 3. So it's pi over 3 times k, or you could just write that pi k over 3. It's up to you, where k is an integer. So let's see if we've done everything we're asked to. We stated the period, that's pi over 3. We have the equations of the asymptotes. X equals pi over 6 plus pi over 3 times k, where k is an integer. We graphed 2 cycles, yes. We labeled the x and the y-axis. And we used dotted lines to show where the asymptotes are. So we're done. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.